Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into some mapping diagrams for inverse functions here so we can better understand what's going on when you take the inverse function of a ratio, of a number. Okay, so here we go. Let's get right on it. Let's start off with the sine function, and let's start off with the domain and range. So let's say this represents the domain. So any number in this bubble diagram right here represents an angle in the domain. And over here, ooh, this represents the range. All right, and let's start off with the sine function. Okay, so what happens is you take an angle in the domain of sine, any angle you wish, all right, and you send it through the sine function. So sine of x here, it sends you send an angle through the sine function, so you take the sine of it, you get a number between -1 and 1. Okay, so we say that all the y values or the output of the function has to be between -1 and 1, or in a closed interval notation, -1 to 1 this way. Okay, so there's a maximum and a minimum y value for the sine function. Okay, now when you take the inverse sine of a number between -1 and 1, any number in there, like 1/2, √3 over 2, √2 over 2, any of those types of numbers here, let me write those down. So all these numbers that you saw in the unit circle are all between -1 and 1. So √2 over 2, rad 3 over 2, 1/2. You take those numbers right there, and you take the inverse sine of them. What happens is it takes you right back to the angle. Okay, and that's what the inverse function does. Okay, written this way here, or you can say arcsine, either one. But it takes those ratios, those numbers between -1 and 1, and sends it right back to the angle. However, the inverse sine is restricted, okay, between negative pi halves and pi halves. So all the x values have to be between negative pi halves and pi halves. All right, we're talking about the input values, okay? So now the input of the inverse function is the range of the original function, okay? So you take these numbers between -1 and 1, like √2 over 2, √3 over 2, and you send them through the inverse sine function. It sends you back to an angle. Okay, and these angles, well, let me see. From negative pi halves to 0, okay, that's quadrant 4, and from 0 to pi halves, that is quadrant 1. So you either get a quadrant 4 angle or a quadrant 1 angle. It's either quadrant 1 or 4, and it only get one, okay? You get one output out of the inverse sine function. So let me illustrate something here. So let's say we start off with the sine function. Let's say that we start off with the sine of 30 degrees. All right, now you have to know some basics here. So let's draw the third. We need a 30, 60, 90 here. So let's bring some triangles in here. Or you can memorize the unit circle, however you want to do it. Okay, I just draw the triangle and it gives me everything, believe it or not. So we know, based upon our definition of SOHCAHTOA, all right, sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent, believe it or not, is opposite divided by adjacent. Just that basic little trig stuff right there will give you all your trig ratios, okay? And we know that sine is opposite of 30, which is 1 divided by hypotenuse 2. So this is equal to 1/2. Okay, so we know that, right? Well, guess what? If that's the case, that means if we take the inverse sine of 1/2, okay, and again, that's between -1 and 1, right? What you do is you should get the angle back, okay? If the sine of 30 gives you 1/2, then the inverse, sine inverse of 1/2 takes you right back to 30 degrees, or what we can say is pi 6, okay? Let's try that again. Let's say we take the sine of -45 degrees, okay? And that's negative pi fourths. All right, what do we get? Well, we know sine's an odd function, so this is the same thing as negative sine 45, or pi fourths right here, and that gives us negative rad 2 over 2. Oh, how do we know that? Well, let me draw a triangle here. So let's draw the 45, 45, 90, and it has sides 1, 1, rad 2. And we all know that the sine of 45 degrees is 1 over √2, which is √2 over 2. But it's negative because we're dealing with quadrant 4 there. All right, if that's the case, all right, and what you do is you take the inverse sine, okay, of that number there, which is negative rad 2 over 2, all right, it should give you an angle back in quadrant 4, right? Not quadrant 1 because it's negative. We're talking about quadrant 4. So we respond as -45 degrees, or you can say negative pi fourths. Okay, so it gives you an angle in quadrant 4 because this is a negative number here. Okay, it can't give you an angle back in quadrant 1 because it's not positive, it's negative. But the inverse function only gives you one angle back. Okay, you input a ratio, take the inverse sine of it, you get a number back. This is clearly different or much different than solving equations. Now, solving equations, you can have an infinite number of solutions. Here, when you take the inverse sine of a ratio, you get an angle back, right? It takes the number in the range, it becomes the input of the sine function, and sends you right back to the angle where it came from. That's what an inverse does, okay? All right, now let's take a look at the tangent function. All right, let's take a look at all three functions here. Okay, so now we have let's say we have the domain here. Excuse me, got a little technology glitch here. There we go. Let's say this is the domain of tangent. All right, we got range over here. And let's take a look at the tangent function, tangent of x. Okay, so you take a number, all right, an angle, all right, this is the input, is the angle. Send it through the tangent function, all right? You can get anything you want, okay? The domain or the range of tangent is a set of reals, okay? And then what happens is if you take that any real number there and you send it right back to the angle, okay? That's what the inverse tangent does, okay? You take a real number, take the inverse tangent of it, it takes you right back to the angle where it comes from, but just like sine here is restricted, well, guess what? Tangent is restricted too, and you're going to get an angle between negative pi halves, okay, and pi halves open, okay? There's a slight difference between these two restrictions here. Up here in the sine function, you include negative pi halves and pi halves. And for the tangent function, because it's undefined at negative pi halves and pi halves, it's open, okay? So there's a little distinction there. And again, these angles here, if you're between negative pi halves and pi halves, we're talking about quadrants 1 and 4. If it's positive, the number's positive, the real number I'm talking about, it's going to give you an angle in quadrant 1. If it's negative, it's going to give you an angle in quadrant 4. Let me illustrate. Okay, so let's say we take the tangent of 45 degrees, okay, which is pi fourths, okay? You see the little triangles up at the top of the screen. All right, we know that the tangent, okay, again, TOA now, opposite divided by adjacent, is 1 divided by 1 or 1. So the tangent of 45 degrees is 1. Okay, so you take that angle, you send it through the tangent function, you get 1 over here, it's a real number. Then you take the inverse of 1, tangent inverse of 1, and it sends you right back to the angle. So we say that the inverse tangent of 1 should give you your angle back, which happens to be 45 degrees or pi fourths of radians. All right, because it takes it right back to the angle. And guess what? Pi fourths lives here in quadrant 1. All right, it's between negative pi halves and pi halves. This is what an inverse does. It takes the number, the real number, sends it back to the angle where it came from. Let me illustrate again. So let's say we have tangent of 60 degrees or pi thirds. So pi thirds, okay, and that means we need another triangle. So let me draw this triangle again. So let me draw the 30, 60, 90 this time. Okay, so pi thirds is 60 degrees. It's up here in the corner. Actually, yeah, okay. In fact, let's make it negative, okay? Ooh, let's make it negative. All right, so this is negative 60 degrees, so keep that in mind. 180 divided by 3 is usually 60, so negative pi thirds is negative 60 degrees. And we know that tangent's an odd function, so this is the same thing as negative tangent of pi thirds. So what's that? Well, if you look at the diagram here, the opposite of 60 is root 3, and then the adjacent is 1. Root 3 divided by 1 is root 3. So our answer is negative rad 3. Again, tangent is opposite divided by adjacent. So again, opposite divided by adjacent, root 3 over 1. Simple, right? Okay, so now what happens, now negative rad 3 is over here in the range, right? You take the angle, negative pi thirds, which is in quadrant 4. You take the tangent of it, you get negative root 3. Then you take the inverse of it, and it should send you right back to the angle, right? So you take the inverse tangent of negative rad 3. Now again, this is a negative number, and the inverse function only gives you one angle back, okay? You input a number, and you get an angle back. What angle do you get? Well, it's got to be negative pi thirds in quadrant 4 because it's negative, okay? Or you can respond negative 60 degrees, I suppose. Most of the time we're in radians, so just keep that in mind. And there, that's how it works, okay? It's not actually not that hard. Now, if you have something like this, tangent, let's say tangent of pi 6. Let's just do another one, okay? Now that's 30 degrees, right? Tangent of 30 degrees is 1 over root 3, or commonly known as root 3 over 3. Okay, so you take the inverse tangent of it, of rad 3 over 3, which is on the 30, 60, 90, right there, should give you the angle that it came from, right? Which is pi 6. Now again, this is positive, and because it's positive, you respond with a quadrant 1 number, or excuse me, angle. If it's negative, then you respond with a negative angle, right? Because it has to be in quadrant 4. And that's the idea. Take an angle, send it through the function, you get a real number, and then take the inverse of that real number and sends it right back to the angle. And that's the whole idea of an inverse. Okay, so we started off with sine, then we just talked about tangent. Let's obviously talk about cosine. Let's be well-rounded here. Okay, so here we go. So let's say this is the domain of cosine. Okay, and let's say that this is the range of cosine. Okay, and again, we're going to take an angle here. We're going to send it through the cosine function, cosine x. All right, we're going to get a number from negative 1 to 1 because this is bounded. Okay, it has a max and a min. Okay, you can write it like this too as well. So from negative 1 closed, right, to positive 1 if you want to use interval notation. And then the inverse, okay, it sends it right back. The inverse cosine takes a number, a ratio between negative 1 and 1, and puts it right back, sends it right back to the angle. But this one has a different restriction, okay? The restriction for cosine is from 0 to pi, okay, inclusively. So from 0 to pi, or you can say 0 less than or equal to x, less than or equal to pi. All right, now this right here, if you go from 0 to pi, dealing with two different quadrants, okay, from 0 to pi halves would be quadrant 1, and pi halves to pi would be quadrant 2. So here, when you take the inverse cosine of a number between negative 1 and 1, you're going to get either a quadrant 1 or a quadrant 2 angle, okay, depending on the sign of the number. So let me illustrate. Okay, so here we go. So let's say that we have an angle. Let's say that we have 45 degrees, where we want to take the cosine of 45 degrees. And when we do that, okay, we know that the cosine of 45 degrees is rad 2 over 2. Okay, so rad 2 over 2, that lives in here, rad 2 over 2. And then let's say that we take the inverse cosine of it. I'm talking about the number rad 2 over 2. Well, that should take you right back to the angle where it came from, which is 45 degrees or pi force. Okay, pi force, or you can say 45 degrees. All right, and that's because it's positive. So if it's positive here, you respond with a quadrant 1 angle. If it's negative, okay, if I ask you to take, let's take the cosine of negative 45 degrees. Okay, now cosine is an even function, so this is the same as cosine of 45 degrees, which is rad 2 over 2. All right, actually, yeah. Okay, so now. Actually, no, I don't want to do that example. Let's switch that. Sorry. I want to take a look at something in quadrant 2. Okay, so let's take 150 degrees, let's say. Okay. Now this is quadrant 2, and we know cosine is negative there. So this is equivalent to the cosine of 30 degrees, right? All right. And cosine of 30 degrees is negative rad 3 over 2. Okay, so negative rad 3 over 2. So that means that if I take the inverse cosine of negative rad 3 over 2, okay, which is a negative number, by the way, I have to respond with a quadrant 2 angle. So I got to be thinking the cosine of what angle, All right, gives me root 3 over 2. And again, if you look at the 30, 60, 90 here, just draw it again so you can see it in your sights. You could see that the adjacent of 30, okay, adjacent side of 30 degrees is root 3, and the hypotenuse is 2. But it's got to be a quadrant 2 number, so we can't say it's 30 degrees or pi 6. We have to respond with the proper angle in quadrant 2, and that's 150 degrees. Okay. If you were in radians right here, that would be 5 pi 6. So if you hear 30 degrees, pi 6, and then 150 degrees or 5 pi 6. Okay? And that's how the game is played. All right? The inverse function just takes the number in the range between -1 and 1 and sends it right back to either a quadrant 1 or a quadrant 2 angle. And that is dependent upon whether it's positive or negative. If the ratio is positive, it's quadrant 1 angle. If it's negative, it's quadrant 2. It's that simple. Believe it or not, you just have to get used to it. So practice this yourself. Hopefully this conceptual diagrams, or what are called mapping diagrams, help you understand what an inverse function does. All right, so practice, get good, and I will see you in another lesson. Take care. Bye-bye.